This is Chapter 8, Part 5. We're talking about the initialization of multidimensional arrays with this. I mean, two-dimensional arrays with this thing. If you look at this last statement right here, to initialize the entire row with the matrices that I'm looking at, is if you look at the row, that's the outer loop, and there's a nested for loop inside. And the way how I want to talk to you about this is, let's look at this from the inside going out. I assume that we have a matrix that's going to have row and columns with this thing. So you're going to set this entire matrix, meaning this entire spreadsheet that you have, whatever that size may be with it, you're going to start with set it, initialize it to 0. You're going to do this in the columns first. Okay, so the number of columns, when the column is incremented, column 1, column 2. So when this is incremented, what are you basically doing? You're gonna what direction is the column? Columns are this. The columns run up and down. So column 0, column 0, column 2, column 0, column 1, column 2, column 3, column 4, and then when this becomes to a certain number, you could turn it down to the next row, 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 row. So that's what I want to talk to you about. Is there are things? How do you know to go to what n and then you turn it around? So we're going to talk about that. I'm going to do a problem for you to see the significance of that. Okay, stay tuned. Let's say you want to print. I like this problem. Use a nested loop to actually output a component of two-dimensional with this thing. Always take a look inside of what it is doing first in this thing. Alright, so you're gonna basically, if you remember what the set W is, set W is basically you're gonna set a column of 5. Okay, so if you took a column, imagine if I took a column, every time I call a set W, I'm going to do a set W column 5, meaning I'm going to 5 space aligning it to right aligning. Is going to count and do it from right to left with this thing, right? So that's going to do the matrix output goes here. It's going to put a space next to it, and then it's going to do a C out another column of set W with it. Now remember, you have to use IO manip with this output with this as well. This loop is going to go from 0. It's going to increment in the number of columns with this thing. So it's going to go 5, 5, 5, 5, and at the same time it's going to come across and down to the next row with this thing. So this is just a standard syntax. This is not practical code because you have to know what the number of rows and columns are. So we're going to talk about that. You prompt them to input certain to input row 4 again. Same thing, output, input. That was what we talked about. Here's something you can sum the row with this thing. So you run this loop, you sum the number of rows and columns, meaning what? What are you basically doing? Find the sum of the row 4 with this thing. Is take a look inside of this thing. Add everything up in this row equal to sum. So if I took a look at this entire, why is sum 0 here? 0 needs to be here because I'm accumulating. I'm taking whatever's inside the matrix in the cell, I'm going to add to 0. That's going to equal to the new sum. So I'm adding it to whatever. Every time when I do column, I have to start out with the new sum, and that sum is going to take its place with it. But the key thing is, what is this code? Is basically it's adding up this entire row to have a sum of somewhere down here. And that's what this code is about, is to add up that row. That's what you're looking at. What's strangely enough is that the way how you look at this thing, it has more columns, word column in here, and what you're doing is what you're adding is the row, actually. Okay, just careful with that. Coming down here, here's the next one, sum button the column. So if you took a look at the sum, and if I want to add up the sum of the row in this thing, row is 1, row is 2, what am I adding? Sum of the column, right? So if you take a look at this part of the code right here inside of this, in their for loop, it's adding is this part right here, everything down, and then it's actually getting that update. It's going to add the sum of the column, and then you come out of that column, you're going to actually add the sum of the row. Do you see that? So if it says column here, column. Why? Because you're incrementing across. You're basically adding the sum of the row. So the outer loop, what you see is adding the sum of the row, and the inner loop is adding the sum of the column with it. So I just want to point that out with it, okay? Largest element in each of the row. Okay, so this is something that it's an algorithm that you're going to see. It's going to find the largest of the column, sort it. If this is where the selection comes in, and the outer one is the repetition loop. The if is your selection. If the largest is less than whatever is inside of this thing, then you're going to set the largest to equal to the largest with this, whatever the content of that. So this is going down to the column, and then it's going to look at the matrices, assuming that the first element of the row is the largest. It's going to assign it to the largest with the same basic algorithm with what we're talking about. There's also what's called passing two-dimensional arrays as a parameter to a function. Two-dimensional arrays are passed by a reference parameter to the function. Base address is passed to the formal parameter. So two-dimensional arrays are stored in row order, with this thing. So you can see where the row order actually takes place, and you can actually see how two-dimensional array is stored in what's called the order of the row. When you're declaring a two-dimensional array as a formal parameter, can omit the size of the first dimension, but not the second with this thing. So you can omit the first dimension, but not the second with this thing. Okay. So string in the C++ can manipulate either the data type of the string of the character, some of the compiler. Other data types such as string are not available in C++, such as non-ANSI with it. So arrays of strings with it. So okay, so just FYI with that. Just I want to point out this is a good slide. Is to declare an array size of 100 component type string. List of 100 basic operations such as assignment, comparison, input, output can be performed as a value of the string with the data in the list giving process, just like a one-dimensional array with this thing. So you can use a string data type, and inside of this is processed just like a one-dimensional array that you worked before with it. So here's Snow White. Remember now, this is your null value with it. There's no character, so it compares the Snow White in list 1 with this thing. So here's your Snow White. This is what this is saying. Okay. Another way to declare a two-dimensional array, so you can declare a two-dimensional. Remember now, this is always row and column with this thing. So you can always use the type table matrix, table type, as matrix with this thing. So another way how you can actually declare two-dimensional arrays with this thing. Multi-dimensional array. Like I said, this is beyond the scope for this class. I'm only holding you responsible for this two-dimensional array. So let's say this is the declaration data type, array name, int, expression, and expression 2. Okay. So just to access it, you would call the array and you type in the access. You use the data type to actually declare it, but in order to access it, you have to be able to read and write from it. That's what that's about with it. Read through the summary for me. That's up to you. Really good. I always like to use the summary statements to help you on exams with it. But please read the summary statement with it. And this concludes the Chapter 8 lecture.